Hello everyone. Today we are going to discuss a new topic of producing a CDDS system, and that is method number 3. We have discussed earlier method 1 and 2 in previous lectures. In ion exchange methods, we will combine a drug with a resin. If our drug is of negative charge, then the resin should be of positive charge, and when this drug will go in, into the body, then it will interchange itself with the ions that are present inside the body. If the drug is of negative charge, then it will change itself with a negative ion. Here the ion will take place of the drug and the drug will be released, and the free amount of the drug will be present in the body for producing any pharmacological action. In ion exchange system, resin composed of water insoluble cross-linked polymer are used. These polymer contain salt forming functional group in repeating position on the polymer chain. The drug is bound to a polymer and released by exchanging with appropriate charge ion in contact with the ion exchange group. Here, both these X negative and Y positive are the ions that are already present inside the GIT. Then what is the rate limiting step here? The rate of the drug diffusing out of the resin is controlled by the area of diffusion, diffusion path length, and the rigidity of the resin. What are the advantages of this method? It is suitable for the drugs that are highly susceptible to degradation by enzymatic process. And disadvantage is the release rate of the drug is proportional to the amount of the ion present in the GIT. If the ions are very less, then the less amount can be incorporated inside the body and less amount of the drug will be exchanged with the ions. Release rate of the drug can be affected by diet intake and individual intestinal content. If I have a particular number of ions present in my GIT, then we can't say that the other person will have the same number of ions, because it will be dependent on which type of diet I am taking and which type of diet other person is taking, and secondly it depends on various other biological conditions. This is the diagram. Here small circle which are present inside represent the drug resin complex, and this drug resin complex is coated with a polymer membrane. Which polymer will be used in such case? That is polystyrene sulfonate. And drugs that are used in hyperkalemia can be given by this method. Hyperkalemia means when inside our body level of potassium goes on increasing. High level of potassium is recognized by a term hyperkalemia. Fourth method for making CDDS is method using osmotic pressure. In this system, the flow of liquid into the release unit is driven by a difference in osmotic pressure between the inside and outside of the release unit. The following sequence of steps are involved in the release process. First of all, this type of delivery device has a semi-permeable membrane that allow a controlled amount of water to diffuse into the core of the device. Then osmotic agent, or called osmogens, are present, which will take this water or fluid and may be swollen up. Because of their change in the property, osmotic pressure is produced here. This osmotic pressure will push the drug to come outside, and the drug will come outside from the delivery unit via orifice. What is the rate limiting step? The release rate of the drug can be modified by changing the amount of osmotic agent, surface area, thickness of semi-permeable membrane, and size of the hole. If the osmotic agents are present in less number, then low osmotic pressure will be produced and less amount of drug will be released. Which type of agent will act as osmotic agent? For example, magnesium sulfate, sodium chloride, and sodium bicarbonate. In the diagram we can see The internal part of the drug act as drug reservoir, and this is coated by a semi-permeable membrane, and here is a hole which act as orifice. What are the advantage of this method? This follows zero order kinetic. The release rate of the drug is independent of the environment of the system. And disadvantage is it is very expensive, quality control is needed. Polymer used cellulose acetate, and drug which is present in the market is Calan SR oral tablet. Here verapamil drug is used. Fifth method for making CDDS system is pH independent formulation. Most of the drugs are either weak acidic or weak basic. These drugs will, when injected into the body, will dissolve at a particular pH, and we are going to make its release pH independent. So for this purpose, only a agent which we can use is buffering agent. Buffering agent are mainly used to maintain the pH release behavior of the drug. So when the drug is prepared, whether it is acidic or basic, it is going to be treated with a buffer agent, maybe a single or a multiple buffer agent, and this will decrease the pH dependent behavior of the drug. Polymer polymethacrylate, Udrazit as are generally used for this purpose. Avinja capsule, in this morphine sulfate drug is used. This is the example of formulated preparation, marketed formulated preparation. Last method for making CDDS is low density and high density. In the low density formulation, we are going to convert our drug into a very low density formulation, and if the drug is present in a low density formulation, then it will float into our stomach or into our intestinal part for a longer period of time, and while residing there it will slowly release the drug. What are the property of a drug for behaving such formulation? Drug must be absorbed from the upper part of the GIT. Drug should act on stomach. Drug should be poorly soluble in alkaline media. Drug that degrade in the colon. And another method is the high density formulation. In the high density system, we are converting our formulation in such a dense form that it will settle down at a particular organ or the tissue, and here the drug will be released slowly. The density of the formulation should be as high as 1.4 gram per centimeter cube. How we will convert the drug into a such dense formulation? We will coat a heavy core or a mixed our drug with the heavy inert materials such as barium sulfate, titanium dioxide, or the zinc oxide. Then these pellets can be converted or covered with a diffusion controlled polymer. Polymer that is going to be used here is the ethyl acetate, and the marketed formulation is Medopar. Here levodopa and benzaldehyde is the drug that are present in such formulation.